Let me stop presenting for a second. Ugh, they're bad. All right, so when you go to take the test on this, okay, in your trig book, okay, so in your trig book, if you go to the back, okay, and you open that back cover, you want to go one page in. There's like a harder page that's a little bit stiffer. That right there has your unit circle, and it has all of these formulas on it and all the identities in one place. So that is a super good resource. Hello, Millie, for you to use during your test. Okay, so please, please, please take advantage of that and use it. When you're doing homework, I just open to that page in the book. Okay, so you've got it all in one spot. All right, I'm going to present again. So our goal is we're going to try to get through. I'm going to go up to example 8. I'm going to skip a couple. Okay, so we're going to try to get the idea here, and then we will give you the homework includes, there's 2 problems from Friday and like 4 or 5 from today. Okay, we're just going to get a taste of what this is about. All right, so we're going to talk about the double angles. There's a lot of different ones of these, and they're all kind of jammed into one lesson. So what's going on? Tell me in the chat. What do you guys remember? What are we taking on Thursday and Friday? We are not going to finish the 10-4 notes. Okay. All right, what's going on with Wednesday, Thursday, Friday in this class? What are we going to take? Taking a test. What's it called? There we go. Good job. Okay, so tomorrow we're going to do a little bit more a last-minute review for that, okay? Because we're all going to try really hard on that. I will try to tonight get the scores out to you. So that way you guys know what you scored last time. So hopefully you can improve that score this time. Remember, improving it at least by 1 point gets you an extra 50. If you improve it by 10 points, I'll give you an extra 75. Okay. All right. So we're going to focus on double angles. All right. I'm going to plug in so I don't die in the middle of this. Okay, so you'll notice that there are 4 or 3 different ways to do double angle there. One for sine, cosine, and tangent. The way that you know you have a double angle is, see right in here how it says 2 times u. So if you're doubling your angle, that means you have a double angle. Okay, yeah, the screen looks super fuzzy, doesn't it? Sorry about that, guys. All right, so, and it's funny because every time I turn it on, it looks different. So like this time it's big, sometimes it gets small. Yeah, I don't understand it. All right, so for sine and tangent, we only have 1 formula. For cosine, we've got 3, and it doesn't matter which one you use. Sometimes one's better than the other depending upon your situation. Okay, so you just have to kind of go with whatever situation you've got there. Okay, and sometimes you can just pick any one you want, and it really doesn't matter on that one. All right, so we're going to review a little bit. I am going to add an X into this angle right here. Okay, so looking at that triangle there, what is the sine of that triangle? Tell me in the chat. What's the sine of that triangle? What do you guys think? Yep. All right, I'm seeing a lot of 8/17s. Good. Okay, what's the cosine of that triangle? Tell me in the chat, what's the cosine? You just got a good one. It sparked really good. All right, I'm seeing a lot of 15/17s. Perfect. Okay, it's not listed there, but we're going to need it here in a minute. Let's do the tangent as well. So what's the tangent of that triangle? Good. Okay. I want to see everybody in that chat participating. Seeing I'm enjoying seeing all the names today. All right, so 8/15. Perfect. All right, so now it says, and we know we have to go double angle because now it says 2x. And notice I left some space in there because there's going to be some work involved in this, right? So it does not matter which one I pick. I'm going to start with this one here. I'm going to choose cosine squared minus sine squared. So all I have to do is take the cosine and square it and subtract the sine and square it. So I already have the sine and the cosine values based on the triangle. So I know I'm going to go 8/17 and 15 over 17. All right, so I'm going to square those numbers, which would give me 64 over 289, I believe, minus 225 over 289. All right, and then I feel like I did something backwards. Oh, you know what I did wrong? I swapped where they were, didn't I? I was supposed to be cosine minus sine. I am sorry about that. We got to fix that. We want to get the right answer, not the good wrong answer. All right, so it's supposed to be 15 over 17 and 8 over 17. 225 over 289 minus 64 over 289. Give you a couple seconds to fix it. Yes, Angelica, Amy and Angelica both tried to stop me and I didn't look up. That's why I always work with my answer key. Even though I know how to do this stuff, I always put my answer key in front of me just so when I mess up, I know I've messed up. All right, so 225 minus 64, I believe, is 161 over 289. And you'll notice when we do these, you'll see the same numbers kind of repeat throughout the problem. All right, so what is cosine the reciprocal of? Tell me that in the chat. What's cosine the reciprocal of, everybody? Good. All right, I'm seeing a lot of secant in the chat. Nice work, everybody. All right, so right now, that means I get secant as kind of a freebie, right? So I'm going to go down here. Look, I didn't even give you enough room to write the work, did I? I'm just going to say 289 over 161, okay? Technically, we don't really have a formula, double angle for that, because we can just flip the cosine. All right, let's try the sine. So let's see, sine said 2 sine times cosine. So this one is 2 sine times cosine. So I'm going to put sine in first, 8 over 17, cosine in second, 15 over 17. Okay, so I got to multiply 2 times 8 times 15, which I believe comes out to be 240. And then 17 times 17 is 289. Done. That one was nice, right? The upside is we didn't have to really mess with common denominators or any of that stuff. All right, so what do I get for free with sine? What's its reciprocal? Help me out in the chat. What's the reciprocal of sine? Okay. Cosecant. Good. So I'm going to have cosecant is going to be 289 over 240. Okay. The tangent formula is a little bit different than those. Kind of got its own animal here. 2 tangent over 1 minus tangent squared. So 2 tangent over 1 minus tangent squared. So we luckily found our tangent. We can always find it if we need to later if we don't have something. So 8 over 15. I'm going to go across here. So across the top, I would end up with 16 over 15 divided by 1 minus, and then we're going to square the 8 and the 15. So we get 64 over 225. Now we need a common, I'm only writing out a lot of steps because I want to make sure you don't miss anything. So common denominator of 225. So 225 over 225 minus 64 over 225. That one door open was just amazing, wasn't it? It was. I had it like I wasn't getting dive bombed, and now it's terrible. The three of us, I can see us all shooing them away. All right. Or maybe it's just one fly that just keeps jumping for the three of us. I don't know. All right, 225 minus 64, we get 1. Is it 161 again? Make sure my arithmetic's right. All right. To get rid of the complex fraction, we have to multiply by the reciprocal, right? So 225 over 161. I know, and I'm being very sloppy about my work. Normally I would want my work to keep going straight down. I'm just trying to fill in the space though. 15 goes into 225 15 times. 16 times 15 is 240. And then for we have to flip the reciprocal. This is the longest one. There's the next couple are not pretty, but they're not quite as long as this one. Okay, I'll give you a minute to catch up. Okay, let's take a look at example 2, okay? So we're going to find the exact solutions of the equation algebraically. We're on the interval 0 to 2 pi, okay? You'll notice in here, we have the double angle going on right there, okay? So what I am going to do is I can't really solve anything with the double angle hanging out in there. So I am going to try to substitute in for my double angle. So I'm going to go look up what my formula is. I'm going to go to my chart and I'm going to notice, oh, I get to substitute in 2 sine u cosine u. In this case, I think it was x's. So for this chunk here, I get 2 sine x cosine x. They're equivalent, right? And then I'm just going to write out my other pieces. Oh my gosh. All right, so I am going to look at this right here. And I'm going to try to do something with it. I want to try to solve. One of the things I can do to solve is look for a greatest common factor. So in the yellow group and the blue group, is there something that they have in common? What do you guys think? Put it in the chat for me. What do they have in common? Okay, I like the cosine x. Oh, look at what Roxana said, everybody. Roxana noticed a 2 cosine x. So we get 2 cosine x gets the factor out. I'm only seeing, let's see, 2, 4, 6, 8 people. There's way more than 8 people in this room. So you all need to help me out, okay? I need to see you participate in that chat. So 2 cosine x, and left behind, okay, remember that in front of every term, there's always an invisible 1. So this first one would be a 1, and then the only thing left in the yellow would be sine x. Okay, so we've done our factoring. We're going to get out good old zero product property. Okay, so I'm going to set both of these equal to 0. So 2 cosine x equals 0, and 1 plus sine x equals 0. If you don't have your unit circle handy, you're going to want it. Okay. All right. I am going to, there's one sitting back here. There's single use, right? Single use, but you know where to go. All right. Everybody's digging out their unit circles here in class. I'll pause till we got them out. There we go. We're ready now. Okay. Here we go. So I am going to, you guys should know that, right? At this point, we use the unit circle almost every day, right? Okay, so we're going to go ahead and divide by 2. We've got cosine of x equals 0. I'm going to subtract 1, so sine of x equals -1. All right, help me out in the chat. What is, that's like 3. We're doing great. Getting rid of those flies. You don't even know how exciting it is in here to get rid of the flies today, you guys. All right, is cosine the x value or the y value, everybody? Cosine the x value or the y value? I'm looking for a unit circle, so I'm going to try to find one here. All right, in your unit circle, I want you all to go find 2 places where that x value is equal to 0. Put those 2 radian measures in the chat for me, please. You can press enter now, that's fine. Okay, I'm gonna, found my unit circle, I'm gonna bring it back down here. Okay, I'm gonna put it right there. Okay, so I'm seeing pi over 2 and 3 pi over 2 from still about 8 people. Oh my goodness, what happened there? That did not paste where I wanted it to go, did it? Let's try it right there. See if I can get it to go in a good spot. Okay, there we go. So let's just check that really quick. So 0 pi over 2 and 0 3 pi over 2. So I agree with that. So x equals pi over 2 and 3 pi over 2. What about sine? Where's the y value equal to -1? Everybody tell me that. Where's the y value? There's only one place. Where's the y value on the unit circle equal to -1? All right. Hope there's more than 8 people with me right now. I need to see you participating. Okay, so -1 and it's 3 pi over 2. So x equals 3 pi over 2. Perfect. All right, so that finishes that one off. We are going to do 3, but we're not going to do 4. So if you need extra space for 3, use 4s. Okay? Okay, let's try this again. So looking at what we have here in example 3, okay? Where is the double angle? Is it in the sine or is it in the cosine? Remember, you're looking for like 2 times a variable. So is this double angle in the sine or the cosine? Help me out with that. Yeah, good. Let's see what everybody says here. All right, good job. We're recognizing that it's in the sine. Perfect. It's right here. Okay. All right, so that means I'm going to replace that piece. I'm keeping sine x and I'm keeping cosine x. So I'm going to go look it up again. And I know I'm doing a lot of scrolling looking up, but it is what it is. All right, so I'm going to substitute in 2 sine x cosine x. So 2 sine x cosine x. All right. I know what you guys would say. You'd say, hey, distribute that in. It isn't a distribute. It's technically just a multiply because this is only one term. So we would just multiply sine times sine and get sine squared. So I have 2 sine squared x cosine x equals cosine x. I don't really know what to do with it at this point. Other than let's see what happens if I bring this cosine to the left. So I'm going to subtract the cosine over. So 2 sine squared x cosine x minus cosine x equals 0. Okay. Any ideas on what I should do from there? So what do you think we should do from there, everybody? What do you think I should do from there? Think about what we did on the last one. Is there something they have in common? What do we call that? Got a few people. All right. What is the G? Okay, now that you've identified that, what is the GCF? What do you guys think? What's in both terms? It's in both terms. Okay, I'm seeing cosine. All right. So I'm going to pull a cosine out. So cosine x out. I have 2 sine squared x. What is in front of this cosine right here? What do I have left when I pull out the cosine? Good. Got another one. All right, I want to see everybody, not just 6 or 7 people. Come on. You got to stick with me. Okay, good. All right, we're going to set it equal to 0. Down to the good old zero product property, one of our favorites, right? So cosine of x equals 0, 2 sine squared x minus 1 equals 0. All right, I'm going to solve the right side. So 2 sine squared x equals 1. Sine squared x divided by the 2, I get 1/2. And take the square root of both sides. What am I supposed to write out in front of the square root? I just took the square root of both sides. What do we have to do? Good. All right, good old plus minus. The square root of 1 in the numerator is 1 over square root of 2, which we don't like that, right? And that's technically doesn't look that way on a unit circle, so I'm going to rationalize it for like the 5 millionth time. So plus or minus square root of 2 over 2. Okay, we're going to go back to our unit circle, and I'm going to look for where the x value is equal to 0. I think we did that in the last one, didn't we? The x value, I'm going to erase a little bit. X value equal to 0. So x value equal to 0 at pi over 2 and at 3 pi over 2. So I'm going to write that down. Pi over 2, 3 pi over 2. Oh, that's like 5. Yeah. It's bad when sometimes they'll go back and forth. Oh, look, that was 7. There we go. Did you guys see that one flash? Oh, it flashed pretty good. All right. So this here, you guys, is sign the x value or the y value? Sign the x value or the y value, everybody? Yeah, it's the y value. So I want to find everywhere where I have a y value that's either positive or negative square root of 2. So we're going to have lots of answers this time. So let's see, I'm going to get pi over 4. I'm going to get 3 pi over 4. I'm going to get 5 pi over 4. I'm going to get 7 pi over 4. So I've got lots of answers, all the over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I'm going to write that a little bit nicer. So it is possible that you get lots of radian measures, okay? They all should still, though, be between 0 and 2 pi. And even the ones on the homework, and I had to do WebAssign, but even the ones on the homework are, look at that. That was 8. I wonder if we'll get to 10 before the end of class. Double digits before the end of class. All right. So there could be lots of angle measures in there. All right, let's try the next one. We're going to talk about 5. We're going to skip 6, though. So if you need some more extra space, use the space for 6. Okay. This one's a little bit on the longer side, but 6 and 7 are literally, no, sorry, 7 and 8 are literally 2 lines apiece. Okay, so they're short. Okay, nice and short. All right, so we're supposed to find exact solutions. They want us to find, and again, we know we're double angle because it says 2u, cosine of 2u, and tangent of 2u. It specifically says use the double angle formulas. Really, we did one like this early on, but we didn't have, they gave us the triangle. So now they're not giving us the triangle and we got to figure it out. So I want you to tell me, it says we're only allowed to be between 3 pi over 2 and 2 pi. What quadrant does that mean that we are located in? Can you guys tell me what quadrant am I located in if I'm between 3 pi over 2 and pi over 2? Put it in the chat. Good. All right, we've got this down. Good job, everybody. We understand that we've had enough repetition on this, right? We beat it to death, haven't we? All right. I bet that when we retake the that other test, you're going to do way better, aren't you? Because we've done it 5 bazillion more times. All right, so I'm going to draw a picture of mostly quadrant 4 here, and I'm going to draw a triangle in it. Ugh. That one was just all over my face. Okay, so I'm going to put my angle U in there. Cosine is the adjacent over the hypotenuse. So my adjacent is 5, my hypotenuse is 13. What's my opposite legs measure supposed to be? Can anybody tell me? Put it in the chat. What's the opposite legs measure? What do we think? Opposite legs measure. All right, I'm seeing some 12s. So, Alondra. Look at what Alondra put, everybody. -12, because look at the direction I'm going. Aren't I going down? Anybody want to revise their answer? Anybody want to revise? Oh, yeah, our brains are growing today. Our brains are growing. All right, so because of the direction, we put that -12. And if you think about it, something has to be negative because we're in a negative quadrant, right? So sine is going to be negative down there, so we need to be able to take that into account. All right, we've got cosine. I know I'm going to need sine to do the double angles, and I know I'm going to need tangent. I might as well write both of those down right now. So what is the sine of that triangle? Help me in the chat. What's the sine of that triangle? The sine of the triangle, everybody. Hoping there's a delay. There it comes. There it comes. Okay. So the sine is, looking for something. All right. So is the negative 12 over 13. Okay. All right. Tangent would be negative 12 over 5. All right. Because opposite over adjacent. All right. So I'm going to find sine of 2u. I'm literally going back up here. And I'm picking up my formula, 2 sine cosine. So 2 times the sine, negative 12/13, times the cosine, 5/13. All right, I'm multiplying across the top, across the bottom. I know that 2 times 5 is 10, times negative 12 would be negative 120. 13 times 13 is negative 169. All right, cosine of 2u, I've got lots of options, right? There were 3 different options. It honestly does not matter at all which one we use. So since I already used the cosine minus sine, I'm going to go for this one next. So cosine, 2 cosine squared minus 1. So I'm going to say that this is 2 cosine squared of u minus 1. So 2. All right, I need my cosine value, which is 5 over 13. All right, 5 over 13 squared would be 25 over 169. I'm going to use my space. They said I could. 2 times 25 would be 50 over 169. I'm going to work smart and not hard, and I'm going to rename the 1 to 169 over 169. Something doesn't seem to be going right, because I shouldn't be negative on cosine, should I? Let's see. Where's my answers on this one? Not there. No, I got negative. Okay. Oh, because it's a double angle. Maybe that's why. It's not a... Okay, so 50 minus 169 is negative 119 over 169. All right. Finally, tangent of 2u. I'm going to go peek at my formula one more time. So tangent was 2 tangent u, 1 minus tangent squared. So 2 tangent u, 1 minus tangent squared. 2 times the tangent over 1 minus tangent squared. Okay, so my tangent we said was negative 12 over 5. All right. So we've got negative 24/5. I'm going to not write the 1 yet. Okay, so I'm going to square this guy first. So that's going to make it positive 12, but we've got negative from the formula, 144 over 25. So instead of writing 1, I'm going to write 25 over 25. I'm working smart and not hard, right? All right, negative 24/5 divided by negative, I think it's 119 over 5. Okay, double negative going to go positive, and then remember to get rid of the complex fraction, we flip and multiply by the reciprocal. Something's not right. What did I miss writing? This should be a 25, not a 5. 25 over 119. 5 goes into 25 5 times, and then we do some multiplication, and we get 120 is 24 times 5 over 119. Last ugly one, I promise. That is it on the ugly. You're gonna like the next ones. Like if you want to, we want to do some double angles on the test. This is the next 2 are the ones we're gonna want. Okay. So it says use a double angle formula to rewrite the expression. Basically, we're gonna go the other direction because do you notice there are no double angles sitting in there? It doesn't have a 2x inside the trig. So I'm going to rewrite this to try to get it to look like something I had up there. So I'm going to say that this is 2 times 2 sine x plus cosine, or it's not plus, sine x times cosine x plus 1. Do you see this piece here? I can replace with this guy up here. With, where is it? Oh, did we hit double digits yet? That was only 9. Oh, bummer. Okay, so we have this guy. I can replace him with sine of 2u. Probably hit at least 50 if we really tried. There's that many of them in here. All right. And then we've got 2, and then we're replacing it again with the sine of 2x plus 1. Done. That one was nice, wasn't it? That's it. We want those ones on the test, right? We don't want the other ones on the test. We'll see how nice Mrs. Ballard is when it comes time for test day. Depends on how, excited I am about writing the test. All right. My motivation lacks at the end of the year, just like yours does. All right, looking at example 8. If we weren't worried about there being any trig in there, doing any kind of replacement, you see a binomial times a binomial, what are you going to do? Tell me in the chat. I haven't heard from you in a while. I've done like 2 whole examples without your help. All right, we're going to FOIL. All right, I want you to examine that particular binomial times that other binomial. I want you to tell me, do I really need FOIL? Oh, let's see. Okay. All right, who knows what those are called? I'll give you extra bonus stars for the day. Who knows what that's actually called when I just do first and last? What is the relationship between the 2 binomials? It has a funny name. I know, but it has a special name when they have the opposite signs like that. Does anybody know it? Starts with the letter C. Anybody remember the name of it? No, not today. Okay. They're called conjugates. Remember that funny word, conjugates? I agree. Jose tried. Jose tried something like that. You got close, Jose. Next time we'll get the stars, okay? All right, at least you tried. At least you tried. All right, so first and last only because we recognize the conjugates. All right, so cosine times cosine is cosine squared x. Sine times negative sine is negative sine squared x. Now I'm thinking that looks kind of familiar. I'm going to go check out my double angle formulas. So let's go check them out. I'm looking for cosine squared minus sine squared. Cosine squared minus sine squared. You guys could probably get to them faster. Look at this right here. I just get to substitute in cosine 2u. That's it. And I'm done. Isn't that nice? All right. And it's just cosine 2x. Done. Easy peasy on those. Okay. All right. Andy fell down on his job. It was Monday, so you can't completely blame Andy for falling down on the job. Mondays are never good at the Ballard house trying to get out the door. So I've got a joke for you. Are you ready? Okay. Why shouldn't you let advanced math intimidate you? It's just as easy as pie. All right. Okay, you guys. I did post. So what I did was, you're going to do the first 4 from last week. The notes, I put those up there. It's just 4 examples and then the summary on the last page. Get that scanned and put up.